Hello, nerds. This is the fourth section of radicals. Oh, I'm blind. I'm blind. I can't see. Float on top. We're looking at adding and subtracting radicals. Radical. Radicals are like a square root, but sometimes there's an implied 2 when you take like the square root of 25, which gives you 5. I think we've already covered this. But like you can have a cubed root of 8. Cube root of 8 is 2 because 2 multiplied by itself 3 times is 8. Anyway, radicals don't just have to be square roots. They can be any roots you want. And what we're going to do today is add and subtract them. Get excited. But it's just like adding anything. If you have 3 ducks and 4 ducks, if you add them up, you get 7 ducks. If my head was out of the way. I assure you, there's 7 ducks. If you had 3 y's and 4 y's, if you added them up, you guessed it. But I can't click it, apparently. Somewhere in there. You'd get 7 y's. And if you had 3 root 5's and 4 more root 5's, you'd get 7 root 5's. So if you have 3 square root of 5's plus 4 square root of 5's, you get 7 square root of 5, just like anything else you're adding up. Neat. So we're going to try these 2 out. You'll try these 2 in your practice packet, and it'll go like butter. So this is 3 root 2's and 4 root 2's. That's like 3 ducks and 4 ducks, right? 3 ducks and 4 ducks gives you 7 ducks. Same thing here, 5 root 3's, but I'm taking away 6 root 3's. This is kind of like saying, I don't know, 5 meters minus 6 meters. You get negative 1 meters, right? So you should have negative 1 root 3's. It's just like saying 5x's minus 6x's. So if you try these, it should be the same thing. This should end up being, well, pause me and try it. Okay, so 5 root 3's and 2 root 3's, if you thought about those as like x's, you'd have 5x's and 2x's, you'd get 7x's. Do the same thing with root 3's, 5, 6, 7 root 3's. What's the actual value of 7 times root 3? I don't care. Nobody cares. It's like 10. If you really want to know, put it in your calculator, but I don't need like a value. I don't need a decimal. That's a perfect value. 7 root 3 is a perfect value. Do the same with this. This is 5 ducks minus 2 ducks. 5 root 3's minus 2 root 3's. So 3 root 3's. And you could leave it as 3 root 3, which means 3 times the square root of 3. Square root of 3 is 1 point, who cares? So it's 3 times 1 point, who cares? But leave it like that. 3 root 3 is an exact value, and they're easy to work with. Because watch this. If we pretended if this was supposed to be 1.427 blah, 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 that goes forever. It's not. I'm making stuff up. But if you wanted to make this 3 times as big, you'd have to multiply that by a 3, and 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 that by a 3. If you want to make this 3 times as big, what's nice about this radical form is if you had 3 x's. And if you want to make it 3 times bigger, you multiply by 3, and you have 9 x's. We don't have to mess with the x. I'm not multiplying the 3 and the x and the 3 and the 3, just the 3 and the x, right? I have 3 pizzas, and I want 3 times as many, 9 pizzas, right? Same thing here. If you want to make this 3 times bigger, you just say I have 3 root 3's. I want 3 times as much, so now I've got 9 root 3's. And it's just a lot easier to work with. Great. I guess this was out of your notes. You could try that your turn. You already did it. Great. Here's another example if you want to see it. Cameo? Mr. Gilliot? Here. We're doing radicals.
Oh, wow. Awesome. What's that weird tick thing?
Tick thing.
Oh, it goes with the numbers. That's cool, man.
Good to see him. All right, so sometimes you get things that aren't the same, that you can't add together, like 3 ducks and 2 frogs and 4 ducks. You get frog ducks if you add those up. No, you just don't add the ducks and the frogs together. You can add the ducks and the ducks together, right? You say I've got 7 ducks and 2 frogs. Do the same thing with radicals. I have root 5's and I have root 3's. Oh, and I have some more root 5's. We'll put the root 5's together. and move on with life, right? So I've got 3 root 5s, 2 root 3s, 4 root 5s, add up the root 5s because they're similar. They're same animals, like ducks and ducks, and then leave the root 3s separately because you can't combine them, right? It's like saying 3x's, 3x's, 2y's, right? It's the same idea. You can't put the x's and y's together because they're different animals. Called terms, like terms. You can't add unlike terms. Great, so you try. See if you can try this. You can pause me. You can wait for me, but pause me. Try it. Go. Okay, this is like 4 root 5s. I'm going to underline it in green. Here's a -1 root 5. If it helps, put a 1 in front of it. And here's root 7s and more root 7s. Well, put all the root 7s together. I wonder if they did that. No, they didn't. And so how many root 7s? Oh, you get 5 and 3 more, so 8 root 7s. Those are all jammed in here. And this is 4 root 5s minus 1 more gives you 3 of them. Ta-da! Great. Okay, so here's a problem. This is root 12 and root 27. And they're not the same. I can't put them together. Do we cry? No. Why don't we could just back off of it if they're like root 5s and root 7s, but these can be simplified. And so let me show you how to do those briefly. I think we've gone through simplifying radicals. But if you haven't, I would think about this as break this up with some perfect squares. So I'd call this 4 times 3. I'm choosing 4 because it's a perfect square. I could choose 6 and 2, but neither of those are a perfect square. And so this really equals root 4 times root 3, which is really like saying root 4 times root 3. I wish I could draw faster with my finger, but I can't, sorry. And this is like saying, 27 is 9, 9 and 3. And we can break that into root 9 and root 3. What that lets us do is say root 4 is 2, root 3, and this is 3 root 3s. And now we got a ball game. We can add them together, right? I think that's what's happening here. Bing. So, do you lie down, try not to cry, and cry a lot? No. You just see what the radical values these are under their disguises. So, I know it looks like a root 12, but it's really a dog in a velociraptor costume, right? Or a dog in a walrus costume. Or, okay, fine, what? I'm sure we got others. A cat in a rabbit costume. He looks so mad. A dog in a lobster costume. A lizard in a shark costume. Okay, I'm done. What this helps us do is take things that look pretty gross and like make them look a little more approachable and squish them together, right? Simplify. I'd like you to try that in 5D, run through them all, or as many as you can without your eyeballs falling out, and check your answers and high five your friends. Okay, bye.